some of the example of the substrate. And this is a technical alat that you use. So this is some of the characteristics and example of application. All right, so I won't go details on this one. So just to show you the coating material. So this is a component of the spray system. You can see here, so this is the substrate preparation, the first one. So you must ensure that the substrate was actually surface roughened so that it can actually adhere some of the coating material. Otherwise, there will not be additions between the coating materials and the pipe. And the second process is generation, spray gun of the energetic gas flow. So you can actually have very high energetic gas flow to ensure that the spray pattern is what I mentioned just now. So the spray of in these areas, it's not only small areas. So this must ensure that the spray pattern is actually cover the whole, cover this area, right? So the spray pattern must ensure that it cover this area. So the third one, definitely you must fit the stock. Either you use rod or you use powder or wire. So when the gases plus your molten salt will be interact. So there will be energetic gas particle interactions. So it means that the gases and the particle that was melt will be interact each other. So the accelerating process from the gas will actually make this drop molten punya atom punya dalam molten atom tadi deposited on this one. You can see here that the particles is actually flatting. So we call this one is splat. It will actually drop on the surface and become like splat. Dia akan jadi macam splat, bertindan-tindan macam ni. So you can see from this, you can see here, so this is the droplet of the molten atom. So you can, they will form splat. So in this cross section, you can see this is the substrate. You can also have unmelted particle, which is also together accelerated by the gas. So you can also have oxide particle that form. You can also have porosity because when the splat is actually stacking on each other, so definitely some area will have a porosity. It will not cover all the areas with the splat. So you can see here some porosity here. So there might be porosity over here. So this is will actually a schematic diagram of the thermal spray. So even you use high velocity or you use flame or you use arc, so this will be your coating structure that will form on the substrate. Okay, so I just show you this is the diagram for flame spray. So we can see here we are using the feed wire and this one is the powder. So the difference is only the feedstock. And this is actually the concept of we are using the arc, electric arc. Tadi kan pakai spray flame. Flame kita guna fuel gas dengan oksigen untuk dapatkan combustion gas, right? So for the second one, we are using electrical arc. So you are actually connecting this one to the voltage. So you can actually create a electrical arc as same as for welding. So ingatkan welding, kita createkan arc spark, right? So sama juga dengan konsep of thermal spray tadi. So in this, we are feeding it using a wire. So feeding the stock using the wire. So this is the coating that we deposited on the workpiece or your substrate. So definitely you require a gas so that this gas will accelerate the molten atom to the coating. If you don't have gas, so there is no power or there is no pressure to actually accelerate the droplet of your molten to the substrate. And this is using a plasma. So instead of you are using arc or you are using combustion gas, you are using a plasma to create the heating process. So for plasma, they are using feedstock of powder. This is just example. They can also use wire. So this is the last one, which is high velocity or sea fuel spray process. So they're also using fuel gas and oxygen, but they also have other carrier gas, right, to accelerate this process as compared to the flame spraying. So they have another gases that is actually include to accelerated high velocities of gases which can accelerate the molten atom towards the substrate. And this is quite small, but you can see the difference here. You can see here that I cannot see the whole there. Okay, you can see here that they are using powder spray. This is flame spray. This is HVOC, and this is the saya tak nampak dekat atas ni. Kenapa? Kita tak nak tutup. So tak nampak dia tulis apa ni. Okay, so electrical arc wire spray, and this last one is plasma spray. So you can see the gas temperature is actually very high. Dekat mana? Dekat plasma, right? Plasma is quite high. So you can see that spray time. So this one is require only, spray time, spray rate, 2.6 kilogram per hour. Which one is lesser? This one is lesser, right? This one also quite less. But this is not only on the spray rate. You have to see the bond strength, the coating thickness that you require, the hardness that you require, and the porosity is the most important thing. But you can see here, HVOF has less porosity as compared to the rest. So they can select the type of thermal spray based on the requirements of the application. Okay, this is some comparisons of the coating process. We have electroless coating or electroplating. We also have CVD, PVD, and thermal spray. So you can see here that the equipment cost, this one is quite low, and this one is moderate, and this one is moderate to high. It depends on the process that you select. If you use a vacuum, so you are using plasma, a vacuum, you need a very high cost. So this one also moderate to high. And coating thickness, you can see here, this is the highest coating thickness, and this is very thin. So we have to select what are the requirement of the product that we want to coat, and based on that, we can select the coating thickness, coating methods that you want to apply the coating on the pipe. Okay, all right, so we have complete on the coating process. We have learned about the electroplating. We have learned about the electroless plating. So electroplating, we have two, electroplating and electroforming. We also learned about electroless. We also have been introduced on the hot dipping. So the most common that you see in industry is galvanizing. We also introduced to you about what is chromating, what is phosphating. So both are actually using this result current. It's it's not electrochemical, it's just a chemical reaction. And we also introduced about the anodizing, and also PVD, CVD, and the last one is the thermal spray. So this is example of defects that can be seen in electroplating. You can see that, you can see a blistering here, blister part, right? So it might have many factors. Either you can actually has a high plating current, or you can also and it's actually entrapment of the hydrogen gas, or you can also have poor addition, means that you not clean properly the part. You can also has, for example, he mentions that when the subject to high temperature, so they will develop a compressive stress. So this will actually lifting the coating. So there are many factors that can lead to blistering. So this is another example still on the electroplating. But on this, we are talking on the electroplating process. It means that what have the parameters that affect the electroplating. So this might be the contamination mask here. How to remove blistering or any coating defects. So definitely you have to rework it. So if let's say you have to redo a process, so it depends on the requirement. Is let's say they should have a certain because defects sometimes you cannot actually avoid. So sometimes they can actually have the what you call the minimum. So this is actually continuations or higher plating in plating bars, in bus plating. So you can actually have some sort like this. So this is also considered for plating as steel plating, electroplating. You can see here that water spot. So this might be caused because of the poor rinsing. So sometimes customers are not happy with this, so they have to go and rework the process. So this might also due to the high iron in plating bars, but most of these defects are only for plating. And this is actually zinc plating and followed by chromating. So you can see here, this is too thick zinc plating. So you can see cloudiness. So you can nampak macam awan-awan. Nampak macam apa? Cloud, right? Kat sini, kat area sini. Ni dan sini. So excess organic in chromating. Okay. When you have, for example, like galvanizing. So galvanizing, so sometimes you can also see blistering. You can also see heating. So it depends on the parameter that you actually see in the use in the process. But sometimes it's not because of parameter. For example, in galvanizing. So normally galvanizing, let's say you want to coat a strip of sheet metal, right? But this sheet metal is not come in one piece like this. So it will be like something like rolling like this, right? So the strip will be mana tu? So dia akan coated di dalam. So there will be continuous process. So what happened here, for example, like in this case for the pinhole. Pinhole, we are doing in process, meaning that the process of hot dipping is come from the metal sheet metal from the when we bought from the customer. So in the coil form, kan dalam bentuk coil macam coil lah. Okay, so after that, they normally will do annealing process to get a homogeneous, to get a structure which is up to the recrystallization temperature. So they want to homogenize the structure. So sometimes they anneal at the recrystallization temperature. So this process is up and down. So there will be a roller, up, down, and up, down. Then after that, then only there will be a process of, like for example, like cleaning process, then only go for galvanizing. So the process is actually starting from annealing towards the cleaning and so on. Then after that, go to galvanizing. So it will be in one line process. So if let's say you see the process of, you see the effect of pinhole, dekat lepas galvanizing. So what should we suspect? Maybe galvanizing ke ataupun proses sebelumnya. So that's why you kena buat failure analysis. So what you can do, normally kalau jumpa pinhole, so what is actually you punya you expect come from the maybe hydrogen embrittlement, kan? Mungkin rasa maybe hydrogen embrittlement in the galvanizing tank. But if let's say, for example, when you do a process of failure analysis, you find that after you remove the coating, you nampak akan ada satu dent. Then lekuk dekat bawah pinhole tadi. Okay, if let's say you remove that pinhole tadi, you remove, then you found that it has a dent on bottom of the pinhole. Okay, so this might be due to incoming. Betul tak? Mungkin incoming material has problem. So macam mana nak kata bahawa incoming problem ke? Ataupun you punya proses masa you buat handling tadi. So you boleh tengok dekat area is surrounding dam tadi. Kalau area surrounding dam tadi, dia punya the what you call the size of the grain is not affected. Maksudnya it's not deformed. So it's let's say you find the grain size surrounding the area is let's say bigger size. So meaning that it might not happen during the process of incoming. So sebab selalunya dalam steel tadi dia akan ada boron. So boron dipanggil boron hardening. So ditambah boron. So during process of annealing tadi, so boron tadi akan jadi boron oxide. So dia akan keluar jadi boron oxide. So this is another reason. So boron oxide tadi dia akan lekat dekat roller. So you the stripe, right? So you stripe, roll supaya dia masuk dalam soaking first annealing. Susah yang saya nak lukis macam mana start ya. Saya tak pandai. Sekejap tunggu sekejap. Walaupun tulisan saya buruk. Okey, tulisan saya nampak tak? Okey, saya tunjuk kat sini dulu. Stop sharing. Semua nak share. Kat mana dia duduk? Sekejap ya. Okay, nampak tak? Nampak tak? Okay, so this is the roller. So saya nak bagi tahu bahawa so the strip tadi, so this is like a roller. Ni roller. Aku nak tulis. So this will be like annealing process here. Aku nak tulis ni. So annealing, so there will be annealing process that was carried out in the process before you do a galvanizing. So during the process of annealing, the boron that inside the steel might be combine with oxygen become boron oxide. So what happen here, the boron akan stick dekat one of the roller. So bila you roll the stripe tadi sebelum dia masuk ke galvanizing punya area, so the boron tadi, boron oxide yang dekat roller tadi akan make a dent, akan jadi buat dents pada you punya part. So the pin is not because of the hydrogen embrittlement. So tadi dekat atas roller dia akan ada boron oxide. So this boron oxide, when the strip was rolled, so the strip was indented by the boron oxide. So you akan dapat dent on the structure. So when this process was actually complete and go to the process of cleaning and so on, and during the process of dipping, so dia akan jadi macam ada lekuk. So the coating tadi is difficult to adhere dekat area lekuk tadi. Okay, so what happened here? So they will be actually gas that entrapped in this process. So after the process of galvanizing, so the gas will be burst out and form pinhole. Ni faham tak? The rest boleh faham tak? Afifi saja seorang faham. Yang lain faham tak? So the pinhole sometimes is not caused by this process. Bukan caused disebabkan oleh galvanizing. It might be caused because of the process before. So you kena tengoklah kat mana masalah tu berlaku. Sama ada memang dekat galvanizing ataupun dekat sebelumnya. So you have to do a failure analysis. Saya lupa saya tengah kelas lagi Cik Ali. Saya lupa balik. Kenapa? Okay. Alright. Okay, sorry ada disruption. Okay, boleh faham tak? Semua faham? Azim faham. Okay. So kalau bila kita tengok area dekat dekat kawasan yang dense tadi besar, so mungkin disebabkan oleh dia dah bila once the roller tadi roll, so it cause a dents, right? So dia akan dapat satu plastic deformation. So dia will be strained inside, strained somewhere at the dents, right? So this material maybe after that will go for annealing, so dia akan jadi some abnormal growth disebabkan oleh strain yang create by the dents. So when you go for the annealing on the second part, because you have many anneal and then after that cooling, anneal and cooling, so there might be a problem on the abnormal growth. So that's why you punya grain akan jadi besar. If let's say the grain is actually some sort distort, it might be caused by the incoming material, because distortion happen masa process of rolling dekat company, dekat factory, because strip is not cast as strip kan. Kalau strip tadi dia tak bukan cast terus jadi strip ataupun sheet, dia must cast sebagai ingot. After that dia akan roll, right? Roll, hot, cool, hot dengan cool rolling. So maybe kalau you nampak dents tadi, you akan ada distortion around the dent, maksudnya grain tu jadi halus. So maybe because of received material, sebab dents tadi berlaku semasa proses rolling dekat company. But this one you receive the material dah dalam keadaan sheet. So bila you tengok dents tu, so means that the areas are bigger size of grain. So kemungkinan dents tu bukan datang daripada received material. It must induced by the process before that, sebelum proses galvanizing. So sometimes the pinhole is not only caused by galvanizing process, maksudnya galvanizing process tadi. It might be causing because of the previous punya process. So this is some example that caused by directly by the pula dah share. Okay, so this example that I show you is directly caused by the plating. So you can see here, this is actually eliminations of chromatin. So you have insufficient cure time, you have excess organic chromatin. So this is actually because of the parameters that involved during the chromatin. Habis dah? Okay. So ada yang tidak berapa jelas. Okay, I have done two question, but I need to do one more question. So I will actually owe you by this evening or saya tak sempat buat hari ni, saya buat malam esok. Malam saya akan hantar dekat Elen. Either by today or tonight. So I have done two questions. So because saya buat hanya galvanizing, so I'll try to do for plating, example the plating. So you can have to do individuals assignment untuk case study for coding. So semua jelas Ada soalan tak? Yeah, I have upload. I have already uploaded. Tadi saya salah upload. Saya dah delete. I upload a news lecture. Saya dah upload. Semua faham ke? Okay, so exam pula, test. Siapa selalu sebut exam Dari kat nak exam ni. Sebab sekarang pun kami kena upload soalan exam. So memang sekarang otak semua exam. Alright, for the test, I not check do a question. The question will be essay. I will give you 1 hour, 1.5 hour to sekali dengan upload. Cukupkah? Ataupun ada request? Sebab saya pun tak tahu you all punya masalah. Sebab saya pun ada masalah internet dan saya faham lah. At my house also having problem of internet from the TM, so I understand. Some of you might satu essay in 1 hour. The essay will have a breakdown of question, but it's not a MCQ question, bukan multi choice question. So I think that will do it in 1.5 hour, but it will be so you have to turn on your camera. So definitely this you have to do I will actually invigilate the exam. So maybe half an hour cukup kot. Saya tak buat soalan lagi. Saya akan agak-agak lah. Maksudnya 15 minit for you to upload the answer. So 1 hour and 50 minutes for you to write down the answer. Handwritten. Tapi bagi cantik sikit boleh tak? Susah saya nak pakai apa. Make sure your handwritten besar sebab susah nak baca. A certain of you your handwritten very small, so susah nak potong. My handwritten and then upload cukup kan because I'm going to set the time. So if let's say you having problems, so let me know now. If not susah lah kalau waktu exam baru you all nak minta tambah masa. Sebelum ni Dr. Nurul buat MCQ ke essay? Upload time tu masa lain kan? Sama. Maksudnya 1.5 hour tu sekali dengan upload. 1.5 hour for you to do test. Sorry, 1 and quarter. 1 hour and quarter. Tak 1.5 jam tu untuk exam, untuk test. Yang lagi 15 minit tu untuk upload. So total 1 jam 30 minit. Dalam e-learn, saya mana saya e-learn ni boleh ke? Ataupun saya buat dalam essay Okey tak kalau saya buat dalam essay e-learn? Tapi susah nak masukkan dia punya